I recognize only a few faces, so it's nice to have some new faces in the crowd. And yeah, I'm going to share sort of the heart of my research program with you guys today. And I'm going to share with you some of the exciting avenues that we're exploring and merging fields of education and neuroscience, which is, I think, in the next 5 or so years, really going to explode certain parts of educational research, and you'll see how it relates to mine. And it's really exciting with some new technology that we have that was recently introduced to Western through the Brain Mind Institute, and hopefully some technology that will come in-house in the next year or two. So yeah, my main research goal, we'll just jump right into it, is to understand how classroom-based physical activity impacts student success. So if I had to put my research goal in, in a one statement sort of piece, that would be it. But as I was writing that, I realized that, I understand what that means because it's my research. But one of the things that really stuck out for me was, well, what does student success even look like? And I think that it can look like many different things. And how do I approach it in my research? So how am I looking to impact student success through classroom-based physical activity? And so one of the ways that student success can be defined is just pure academic achievement. So how students are doing at the end of the school year, what is their grade in a certain course, or maybe, across their entire grade. Another way that you can define student success, though, is how a certain intervention, like physical activity, is impacting what's known as cognitive control. So the cognitive psychologists in this room will know what this means, but it includes these higher order cognitive processes like sustained attention, inhibitory control, so being able to inhibit distracting information in your environment, working memory as a construct. So all of these cognitive factors that are highly implicated in your ability to be a successful learner. So that's another way that a certain intervention can impact student success if it plays a role in upregulating these cognitive control factors. Another factor is enjoyment and motivation. So student success, I think if we can motivate students to really enjoy coming to class and enjoy being in class and learning content, I think that is more than half of the battle, because the learning will naturally follow if there's motivation. So all of these factors play a role in what is called student success from my perspective. And there's probably, I'm sure, a number of other factors that maybe are popping into your heads as well. So yeah, that's how I approach it. And I just want to preface as well and just say that if you have any questions, just please feel free to ask. This isn't meant to be like super formal, me talking the whole time. If you have any questions, please interject. And so I look at this research question all the way from children, so grade 1, up until young adulthood, so university students, because obviously that's the spectrum of how long usually students are in school. So I think that gives us a nice sort of lifespan perspective to also look at. And I look at this research question both in typically developing students and those with ADHD. And so in a few slides, we're going to look at why this research question is really interesting within that subpopulation of students with ADHD. But yeah, so that is the sort of overarching theme of my research. And so why is this research question important? And so this is something that is sort of hammered into you when you're writing research grants. Why is your research important? And I think it's obviously something that really needs to frame why you're doing your research. But one of the main reasons is because there's a plethora of research that shows that regular physical activity promotes cognitive function and scholastic achievement. And this has been shown for many, many decades, and it's a robust finding. And so to break that down a little bit more, what does that mean? What the research shows is that children who are more fit, so that means that they engage in more regular physical activity, have physiological differences compared to their peers who are less fit, such as greater hippocampal volume. And so from a neuroscience perspective, that's a very important brain region that's involved in the formation of new memories. Greater white matter integrity. So white matter is the portion of your brain that's really involved in sending neural signals, and it's what decays the fastest in a lot of neurodegenerative disorders. And they also have elevated and more efficient patterns of brain activity. So you can see that there is a structural and functional difference in terms of brain health in kids if they're more physically fit and physically active. And we see this across the lifespan. I've done some research in my postdoc that looked at the older adult side of this research question. So how does physical activity promote cognitive and brain health in older adults? And it's the same pattern of results. So the idea is that physical activity is supposed to support brain and cognitive health, and this is what supports scholastic achievement. And so that's really one of the main reasons why I approach this line of work. And so what I just introduced to you was that there's clearly evidence with correlational and longitudinal research that shows that there is a repeated accumulative benefit of physical activity that builds and leads to some sort of support for your brain health and for academic achievement, right? We can just see that with these studies. However, more recently, research has started to become more interested in, can a single short bout of physical activity, so let's say a 5-10 minute bout of physical activity, also have immediate positive benefits for your cognitive function, so for your ability to pay attention and for your ability to learn and remember information. And that's really what this classroom-based physical activity research tries to target. And so one of the hypotheses as to why a single bout of physical activity would be conducive in a classroom to help support student attention and learning is rooted in what's called the exercise-induced arousal hypothesis. There are a number of hypotheses as to why physical activity is good for your brain, but this is one that seems to resurface many, many times in this research. And so it goes like this. When you engage in physical activity, that is a form of physiological arousal. And what that means is that obviously your heart rate is increasing, there's more blood flow, but you're also releasing a cascade of hormones. So things like adrenaline, epinephrine, even cortisol is released during physical activity. And what that does is that it increases your vigilance and your attention. And obviously, more attention that you have that you can devote to any task, such as paying attention to a lesson plan, is going to enhance your encoding of information. Now, this goes back all the way to evolutionary psychology is weaved into this paradigm, because the idea is that as hunter-gatherers, you had to engage in physical activity when you were hunting your prey, and through that, obviously, you had to increase your vigilance, and that was increased through your arousal through physical activity, and it was selected for with those people who were more successful at obviously hunting successfully and providing for their families. And specifically, I focus on how this cascade of events really impacts the prefrontal cortical region of our brain. So this is the area, and the brain is obviously highly interconnected, so everything is correlated, but this area of the brain is especially implicated in those higher order cognitive functions. So things like paying attention, inhibition, working memory. So all those cognitive factors that allow you to be a successful student. So coming back to why this, so this being my research question, and it's really important to try to understand whether those short bouts of physical activity, not just having higher fitness in general, can also elicit gains in attention and learning. And so the second reason why this research question is really important is because students spend most of their day in school. 6 to 8 hours a day is spent in school, and it's usually in sedentary behavior. So they're usually either sitting at their desks, on the floor, listening to their teacher, even recess. I know some schools, they don't actually even allow kids to be running on the pavement during recess because it's a physical hazard. I actually knew a friend of mine, her son was like, he got sent home with a letter saying Johnny was running at recess. Make sure, you know, keep your kid in line. And it's like, yeah, I mean, not with those words, but, you know, read between the lines. And it's crazy, but that's the reality of how things are right now. And childhood obesity is on the rise, probably in combination, obviously, with respect to the quality of food that we're eating and all those kinds of things. But sedentary behavior is a really important factor that's implicated in childhood obesity. So I think, and I don't know exactly what led to Ontario's daily physical activity policy, but this was a policy that was instituted in 2005. And that mandates all elementary classrooms or all elementary schools have 20 minutes of instructional time that is devoted to physical activity. So this is beyond recess, beyond physical education classes. So the policy is in place, but as you can see, it's already quite ambiguous because who's going to be the one to adopt that 20 minutes? Because it just has to be within the school day. So, you know, it was sort of the social loafing paradigm. You know, well, me as a teacher, I might not do it because maybe somebody else will do it. So what I'm alluding to is that there was a recent assessment of whether teachers are actually abiding by this policy, and 50% of teachers reported that they don't actually adhere to the DPA policy. And, you know, that's a problem because obviously this policy is in place for good reasons and is likely based on, you know, evidence-based research that they're familiar with, and they recognize the importance of physical activity during the school day, but people aren't doing it. And that's sort of the crux of where my research tries to enter the fold. And it tries to answer, well, why aren't teachers doing it? And so I've tried to identify two main sort of paths that we can take to try to answer this question and try to get more physical activity into the classroom. And so one of the things that we need a better understanding of is the neuropsychological mechanisms that actually underlie the relationship between physical activity and learning. So that's a big mouthful, I know. So what I mean by that is we can see with the longitudinal long-term research that physical activity supports academic success. We see that, but we don't actually know what that looks like in an acute bout within the classroom when it's just introduced in a single bout. And we also don't know what is happening to the brain when kids are engaging in physical activity in the classroom. And I think that's really important because if you can provide multiple pieces of evidence for, well, we see, you know, a benefit of physical activity on their attention and learning, that's one aspect. That's sort of the cognitive educational piece. But if we can also show that the brain is responding, especially those prefrontal cortical regions, in a really positive way, which is what is supporting the cognitive and learning outcomes, that's just another layer of evidence that we can really push behind classroom-based physical activity. And so the other thing that we need a better understanding of is what actually works in the classroom. So I'm really excited to have Peter here from Laurier Secondary School, and I'm going to pick on you a little bit when we talk about Brain Bump is a sort of merged physical activity and math classroom that's been happening for the last 6 years?
6 years.
6 years for grade 9 students, and there's a lot of really positive outcomes that have come out of that. So, you know, it's definitely possible to bring it into the classroom, but maybe you can even speak to some of the challenges that you've had sort of generalizing it to other colleagues who find it a little challenging to bring it into their own classroom sometimes, but we can get into that after. So yeah, these are the two big things that I'm trying to tackle, baby steps. But so if we look at the first question, and that's looking at the neuropsychological mechanisms that underlie this relationship. Yes. Absolutely.
You said we could interrupt your question.
Absolutely, yes.
Okay. So the question I had prior to you getting more specifically about students is, do you have a time is there a specific amount of time that helps induce this sort of, are you getting to that? I don't.
We're going to talk about it a little bit, but yeah, that's sort of, it's kind of up in the air still. That's one of the things that what works in the classroom is going to get into, because there's some evidence that shows just a 5-minute bout should be sufficient, but we don't know how long it's sufficient for. Some people say that you need a 10-minute bout because that's, you know, going to be what sustains attention. And then some people say it has to be longer than that, at least 20 minutes. And I think the way that research works is that every research paradigm is slightly different. So everybody's talking about the same thing, but in a different way. So it's really hard to extrapolate, you know, a specific guideline. But yeah, we can definitely talk about that. And a little bit of what I'm trying to do is figure out what that, you know, that optimal point is for sure. Yes.
And it's kind of a follow-up question about the type of activity.
Yep.
Is it like strength physical exercise or just like a hands-on activity would do?
Yeah, that's a great question, and we are going to get into it a little bit, but I can just answer it now. So there's still some debate about what kind of physical activity is the best that you should do in a classroom, and usually it shouldn't be too intensive. It should be around moderate physical activity in terms of the type. So moderate just means like you're not sweating to death. But you are, you know, getting your heart rate up. There is some physiological arousal happening. And in terms of the type, so it can be purely aerobic, so you could just be doing jumping jacks. But there's more research to support an integrated sort of learning and physical activity paradigm. So let's say you tell your kids to solve, you know, 5 times 5, and they have to solve a number of jumping jacks. So it's sort of a combined, you know, physical activity, cognitive component. And so the verdict is still out on a lot of these things. We don't have definitive answers, but there is evidence suggesting that those combined approaches are the best, probably because it activates more of your brain. There's a lot more things happening, and so it reinforces the information in different ways. But, you know, not every piece of information lends itself to being paired with physical activity. So sometimes you have to separate the two. Any other questions? But yeah, these are great questions and keep them coming. And if there's any sort of confusion at any point, please interrupt me. So to answer the first question, one of the things that I'm very excited about is we're able to merge education and neuroscience in a much more feasible, realistic way. I'd say in the last 2 to 3 years, especially with the advent of what's called functional near-infrared spectroscopy, which just dilutes to FNIRS. And it's a cap that looks like this. So it just looks like a swimmer's cap, and there's a bunch of wires and probes that is just hooked up to a pretty basic piece of technology. It's just the port there and then some screens to actually display the data. But what this technology does, it's a form of functional imaging. So it allows us to see activity happening in the brain in real time. And it's not like an fMRI machine, which is like those big machines that you have to be, you know, shuffled into, and it can be quite claustrophobic, and the operating costs are crazy for those kinds of machines. So functional imaging to see what the brain is doing in response to various interventions has been limited due to, you know, technology, but now advancements are happening so that we have this wonderful piece of technology, and what it does is that it can allow us to see, well, how is something like an acute bout of physical activity actually impacting these frontal brain regions, and what does that mean in terms of how students are then able to pay attention and learn information. So I'm just going to break this technology down a little bit more for you so you can appreciate how it actually works. So it's infrared technology, and what happens is that there's a combination of what are called sources and detectors, and these are the probes that you see on your head here. And the source emits a wave of infrared light, and depending on how much blood there is within a certain region of the brain, the detector will detect a certain concentration of that blood. Let me just backtrack real quickly. So what I should say is that when a certain region of your brain is being used heavily, there's more metabolic demand and more blood that rushes into that region. So it's essentially like an indication of neural activity. So if we can see that physical activity is having a positive effect on these prefrontal regions of the brain, we should see more blood coming into that region. And if there's more blood in that region, there should also be a better capacity to perform well on these higher order cognitive tasks. So this is some really cool technology that we're actively using in the Brain Mind Institute right now. And we're just going to be starting data collection real soon, and I'll show you the paradigm and the study that we're going to be doing. But yeah, this technology really affords us a unique opportunity to merge education and neuroscience a lot more. But does anyone have any questions about this tech? Because I always find it hard to describe this because it's so technical, and I have to like make it digestible, and I feel like sometimes I just don't say enough or too much. Yeah.
So just in terms of the resolution and how far it actually can reach into the brain beyond the cortex into the other systems like the limbic system, how good is the resolution to do that?
Yeah, that's a great question. So the spatial resolution in terms of where in the brain it can actually tap into is very superficial. So it can only penetrate about 1.5 centimeters below the surface of the scalp. So it's just the neocortical region. So it's perfectly fine for things like prefrontal, temporal, motor areas of the brain, but anything that's more subcortical, like the hippocampus, it's not good for that. So maybe in the future, but this is sort of what we're stuck with. But in terms of temporal resolution, so the timing is actually quite high, so we can say definitive things about how a task is associated with blood oxygenation. So let me just actually jump right into, this is Marcus, he's one of my master's students in counseling psychology here, and over the last several months we designed a pretty elegant but simple study that allows us to answer that first research question that we have about neuropsychological mechanisms. So what we do is we have kids come into the lab that we have set up at the BMI, and we administer a series of cognitive and learning tasks to them, so a battery that looks at their attention, their working memory, their ability to learn, and they're also wearing this FNIRS cap while they're doing it. So we get a measure of what their sort of baseline prefrontal function is while they perform these tasks. Then we administer a physical activity component, so they sit on a stationary bike for 10 minutes, and we keep them at moderate intensity. So we moderate their heart rate and make sure that they're not, exercising too hard or too little, because the literature says this moderate intensity range is the best. And then we subject them to the same battery of those cognitive and learning measures. And so from this, we're able to see what happens to neural activity and cognitive function following this intervention. And we're able to just swap out that physical activity component with a control group. The same kids do the exact same portion of the study, but now we're able to compare it to just a control condition. So we're able to see when they're doing physical activity, versus when they're just reading. How does physical activity impact the brain and cognitive function and learning performance as a result? So what we're trying to do is really test a new model where we can see that physical activity, like I've been saying, has clear benefits for learning, but we don't know how this is necessarily happening. So with this paradigm, with this technology, we're actually able to see, well, does physical activity actually have an effect on this prefrontal cortical activation and brings more blood to that region? And could that be enhancing things like attention and working memory? And maybe that's what's supporting learning. So we're able to actually test this. It's called a mediating model. And that's really going to allow us to get more fine-grained analyses and insights into, why would physical activity be conducive to a learning environment. And this is actually an image of one of our kiddos from the Hamilton Catholic District School Board. So we did a 6-week just pilot intervention where they did physical activity in their math classes, and then we would pull them out. We'd hook them up with the FNIRS cap and measure their performance on different cognitive tasks, just to see compared to their peers who who weren't assigned to a physical activity in math class, you know, what the differences in their brain activation were. And so you can see it's very portable, it's small. I applied for infrastructure funding to hopefully bring this infrastructure into the Faculty of Ed, so hopefully that comes through. But so I wish Jackie was here, because so she gave me, this is sort of a little bit of a soapbox tangent, but I had to do it. So I'm prepping for a first year teacher ed course that I'm teaching in September, and one of the books that a colleague gave me to perhaps assign different chapters from this book. This book is written by cognitive psychologists. It's a wonderful tool to guide students on, you know, understanding how we learn, sort of the pitfalls of, you know, misunderstandings about what we think learning looks like. And it's a really good book, but it's written by cognitive psychologists. And so there was a portion of this book as I was reading it, and I'll read you the quote that I pulled out of it. But it said, cognitive psychology observes and measures human behavior and infers underlying mental processes from those behaviors. Since cognitive psychology measures behavior, such as performance on tests, it lends itself better than neuroscience to recommendations for teaching and learning. So, called me out hard on my, you know, vision for education and neuroscience, and it went on and kept, you know, harping on it, and said, while we know a lot about cognitive processes and a lot about how the brain functions, the two fields are still relatively separate, with insufficient understanding of how cognitive processes map onto the brain. So we should focus on bridging the gap between cognition and education, as well as the gap between cognition and neuroscience. But the gap between education and neuroscience is still too wide. So my first reaction when reading this was this. I just wanted to let the book burn. Honestly, like, that's just your normal initial reaction when someone, you know, it feels like someone targets your passion and, you know, your research program. And however, I gave it a few minutes, and I reread it, and I tried to be empathetic and take the other person's perspective and all that stuff. And I realized actually that they have a point. However, the way that this technology works and the paradigm that we're using is actually functioning as the bridge between cognition, neuroscience, and education, because we're able to have neural measures during cognitive tasks and infer what that means for learning processes. So they may not, I think that they were referring to traditional neuroscience and education, where you stick kids and participants into an actual fMRI, and so the brain measure is far removed from the actual cognitive and learning assessments. But now we can merge those two, and so we can say some really cool, exciting things about, you know, education and neuroscience and how they can talk to one another. And so Marcus actually, when he came into the lab, he didn't want to do physical activity, not because he didn't like it, but he wanted to, you know, carve something different out for yourself. And so the way this paradigm is actually set up, it lends itself really nicely to looking at other intervention models that the research shows could potentially be beneficial for student learning in the classroom as well. So just swapping out the middle portion and looking at something like an acute bout of mindfulness meditation, because that research is also taking off. And there's been a lot of positive things around, you know, getting students to practice more mindfulness and how that can have positive effects on cognitive control and self-regulation. And so, yeah, we have this paradigm that we're going to test all kids through, and it's a within subjects study. So participants go through each of these different levels on different weeks. So it's actually a 4-week study. And so we're looking at children in this particular study that are 10 to 14 years of age, and we're looking at kids that are typically developing, as well as those with ADHD. So like I mentioned, I would circle back to why we're looking at this special population, and one of the reasons is because it's the most common neurodevelopmental disorder. 1 in 20 kids are diagnosed with it. And what's interesting is that the etiology of ADHD is actually prefrontal cortical hypoarousal. So what that means is that the prefrontal cortex is under-aroused in these children. And that's why they exert these manifestations of hyperactivity, because they're trying to get to a baseline of arousal that is similar to sort of the population norm. So they have to exert all of this extra activity to get their brain to a similar level. Another reason is because pharmaceutical treatment is the most common approach to treating ADHD. So methylphenidate, otherwise known as Ritalin, is supposed to act on the prefrontal cortex as a stimulant. So it's supposed to upregulate this region of the brain. And kids with ADHD struggle more than their peers academically. So this offers a really great opportunity to not only see how this paradigm functions within typically developing students, but also amongst those who might see extra benefits of physical activity or mindfulness meditation in the classroom. And so this is just a shout out to the model that I put in a grant to purchase. So this one's actually more compact. It's called the Near Sport FNIR system, and you can see it just will either be strapped to your back, or you can have it on your hip. You can carry it around in the real world. You can see so many ecologically valid scenarios where you can actually measure brain activity in the real world. So we can bring it into the community, into classrooms, and see what that looks like. And so again, it's a really exciting time. We're really at the cutting edge of trying to figure out how neuroscience and education can merge. So that's really the first way that we need to gain a better understanding, is to try to figure out what are the mechanisms that link physical activity and learning to really support why it should exist in the classroom. So, but jumping to the second one, another very big, not issue, but thing that we need to consider is what actually works in the classroom, and why are classrooms inactive, and why is there this DPA policy that teachers aren't following through with. And I think the biggest thing that I've come across is that there's a really unclear understanding on the part of the researcher as to what the barriers that teachers face in the classroom when it comes to implementation, as well as the barriers that students face. Do they actually want to participate in physical activity? Do teachers have the time to even implement physical activity breaks? Do they have the resources? Do they know what a physical activity break would look like? And so I just wanted to actually merge this into maybe a little bit of a think tank opportunity, because I'd love to hear what you guys think, if you have any thoughts about what aren't we considering when we because most of the research is empirical scientists that go into a classroom and say teachers do this for however many weeks, maybe up to a year, and we're going to evaluate what this intervention looks like on our end. And then that's it. So it's all very structured from the end of a research model, but when it comes to it existing in the real world on its own, we have very little understanding of what will actually work in the classroom. And I think that we can be doing research for however long we want if we don't have that missing piece where we actually try to understand what are the perspectives of the people in the environment that we're trying to affect. Yes.
For context, I have sons that are in grade 7 and 10. And so I think of, and so what grade of, this is for grade 9s?
So no, that's yeah. So the age groups that we're actually going to be looking at are grades 3 to 8.
Okay, so something that I have I've had sporty children, and so I would think that they would be really keen to participate. However, I think some of the challenges that the researcher would have, what about the kids that are not as, let's say, coordinated?
Right.
And I still think, like, how do you get them moving without feeling self-conscious that they're not as good as the hockey players and the, volleyball players in the room, or this sort of thing. So that is peer stuff,
Yeah.
is what I think of first off. And from that, of course, goes along with the self-conscious, depending on the age, body image.
Right, yeah, 100%.
Yeah, so context, I was an elementary teacher. I was a teacher in 2005 when Fenesi came out, and I was teaching grade 5, so I tried to implement it. Why do things come and go in terms of fashion and policy and education? Everything does, right?
Right.
If you can't sort of sustain long-term a reason for teachers to do something, it'll fall off because there's so many competing demands, as I'm sure you're aware. Earlier in my career, Brain Gym was quite popular, and that was sort of a purchase program. Teachers would go to these fancy workshops and learn these like mind-body supposed exercises that would enhance learning, and apparently there was little long-term efficacy, which always depends on how things are measured, right? So I think it's really exciting that you're looking at more shorter-term measures, and you're trying to make them more ecologically valid, because you're always going to be concerned that what happens in the lab stays in the lab. Motivation and peer, I had some girls in grade 5 that did not want to move, and I could not make them move. Did any more than I could make a kid read or write or do math if they didn't want to. So there's always that, how do we hook people in? And I think it's also really interesting to understand how long, how often, those kinds of questions. How individual can it be? I was doing research in a classroom last year where a teacher, this wasn't my research, but in this classroom, the teacher had a couple of exercise bikes, and the kids were free to come and go on them as they felt like they needed a little boost. But who knows what the effect was, and you know what I mean? Like, those are all interesting questions, so it's a great program of research.
Wonderful, thank you very much. And I think you're totally right, figuring out how often, how long, those are really important questions, and what type in terms of being more inclusive for different abilities. I think that one's really important too. Actually, I got into this line of research years ago, and I initially was looking at high intensity exercise with university students. So things that are aversive for even fit people, but we kind of just wanted to pick up physical activity stimulus that would be sort of the top end of that. And a lot of the researchers, because the data were really interesting, we saw benefits for attention and memory after just a 5-minute bout. However, nobody's gonna opt into doing that in a classroom. I can't see any student, like even if you're just wearing heels and you go to class, as I'm talking about university students, not so much kids, but if your teacher tells you to do high knees or something that's very aversive. So I think it's really important to consider. And I think it's interesting because there's a number of programs that people have access to, even online, that they could just sort of display on a YouTube video, and then kids can just follow, what that instructor's doing for 5 minutes. But there's no real prescriptive program yet, and so that's sort of what we're trying to work towards, while still being open and malleable enough to include, different abilities. But Peter, I don't know if you, in your experience, noticed, different students having different, aversions for various reasons to your.
In high school, we're actually fortunate that
grade 9
phys ed is mandatory.
Right.
And so it's not really that you're kind of implementing activity in the middle of the class, let's say, but it's part of their selection of the timetable. So when they're in a class with phys ed teachers, and then they're in the gym, they're participating. So they can't opt out, basically.
Right.
So that's part of their course. But we run a full year where math and phys ed are together. So they know that every day they're going to get physical activity, they're going to get math lessons.
Right. So they're prepared more.
Right.
Yeah.
And for high school, the fact that we can make it mandatory for them, so nobody can opt out of phys ed, for example,
Right.
or opt out of math in grade 9, then it makes it much easier for us to structure that. The difficulty, though, is finding teachers that will have the ability to teach both. So because in high school, we're obviously subject specialists, so we have phys ed teachers that also have to be math teachers. And so at my school at Laurier, we're fortunate enough that we've had teachers before we we implemented the program, we had phys ed teachers that were comfortable teaching math, so it was an easy fit when we decided to put it all together, which is very rare. So it's difficult to kind of just say, let's kind of expand throughout the whole board and let's have other schools attempt it, because it's hard to ask math teachers, first of all, to teach phys ed. That's probably more difficult than asking phys ed teachers to teach math. So it's very hard to find the balance.
Yeah, definitely not an easy, line of research to fully wrap your head around, because there's so many variables at play. Teacher motivation, student motivation, and then what actually works, and does it work in math, reading, social studies? Does it work in all the different classrooms? So there's a lot to think about. But actually, the second point is going to what you guys were talking about really defining some clear guidelines for implementation. So how many physical activity bouts will be beneficial, the intensity, the type. So should it be something that's more cognitively engaging and physically active? Intensity. I think the intensity question is interesting, but I think it's becoming a little bit less relevant, because I think any form of activity will be better than nothing. So yeah, I think these are really important, directions that we're heading. And so I think by answering these two lines, we will get a better understanding of how to bring physical activity into classroom, but it's really still just a drop in the bucket. And that's sort of something that I have to make my peace with every single time I'm thinking about my research program, is that, you're not going to change the world. You're providing one piece of the puzzle of a very large, complex puzzle, but it's all important. And so I'm just in closing, I'm a huge advocate for converging evidence and having multiple perspectives inform your research program. So as you can see, I use education, cognition, and neuroscience. Some people, discourage you from having so many different streams of science in your research, because they say it will make you less focused, but I think it's more of a holistic, better perspective to have. Not better, but in my opinion, I think that it targets something like student success, which is so complex, in a more realistic way. And so I forgot to mention, but one of the things that we're going to be doing to look at teacher and student barriers is having some qualitative research in there. So running focus groups and interviews with teachers and students, and saying, why would or would you not implement physical activity in your classroom, and what kind of supports would you need? Because then getting that perspective and their actual experiences in the classroom will then inform the researchers on how to approach it. And so all of these things combined, yes.
Sorry, do you also think that there is something to be said in your research for the teachers that agree to do your study?
Yeah, that they're more motivated and wanting to. Absolutely, and I think that...
Is that like sort of, I don't want to say a limitation, but do you guys talk about, would you talk about that?
For sure. I mean, teacher self-selection, any sort of self-selection into a research paradigm always has a limitation, because it has a motivation factor that might not exist just if you randomly force people into your study, which obviously for ethical reasons you can't do. But one of the things that hopefully will come of this is if you can recruit a teacher champion that belongs to each school, that really is for physical activity in the classroom and can be sort of the hub of support for the other teachers, and so that there is some sort of onus at some level. And so, in Peter's case, there's a lot of teachers that are very invested, and like you said, there might not be in other schools across the school board, and that's just the reality of it. So you're never going to be able to fix the whole problem, but if you can get people excited about it and actually hopefully show results that show your kids are actually doing better, they're paying attention. And one of the things that I know you pulled EQAO scores from math outcomes for students that had this combined math and phys ed, and showing the benefits on that level. So I think people will be more drawn to it that way. But yeah, it's still a problem for sure. Yeah, absolutely.
I am quite curious also the gender and what you have noticed in has gender mattered in terms of activity and engagement and the success of, like,
Interesting.
has that made a difference?
So in high school, so we have the phys ed classes running as a boys phys ed and a girls phys ed.
Oh,
So we
okay,
have equal numbers participating in the program every year.
yeah.
And so the fact that all the kids that take the program benefit, now some of the benefits might be just the fact that they get a full year of physical activity. So that's a benefit right off the bat, because our program runs half periods for the whole year. The other benefit is for kids that can't absorb as much in a 75-minute period of mathematics. Because of the fact that they run in tandem, that they only have to do 35 minutes. I mean, even here, when we go to university classes, they don't run past 50 minutes usually, right? Because the kids aren't going to be able to absorb things. You can only get a limitation on how much the kids can actually take. So for some of the kids, the benefit is not just academic. The nice thing about the fact that we're doing it in grade 9 is we have these EQAO scores, and we track EQAO scores from grade 6 and grade 9. So we can see whether we've seen an improvement in their math ability, because first of all, they're all standardized, so nobody's going to criticize that we're just skewing the numbers somehow. We're just giving them easier assessment because it's a full year assessment versus, semestered assessments. So the fact that we can actually track kids with their EQAO scores from grade 6 and seeing how they improve in grade 9, it might be minimal change, it might be just one level improvement, but even those level 1 to level 2 scores, just that kind of a small improvement is worth running the program, right? So I can say it works across the board. And the fact that we have equal numbers of girls and boys that are taking it, we kind of just, some years it's, because then the math is streamed, whereas the phys ed is not. We have to make sure that our classrooms are balanced so that our academic kids, we have enough students to run the academic, the higher level math, and we have the middle road math at the same time. So some years we'll have predominantly girls in the academic, so we'll outnumber the boys, and sometimes it's reversed. But the benefit isn't really to just looking at what the girls are outperforming what they would normally do, or boys are outperforming what they would normally do.
Yeah.
But in that situation, you're talking about kids who are very sports motivated. We try to do a lot of the math activities within sport, so that the kids are learning while in the physical activity. So that gives us one big benefit, that we're not just sitting and learning after the activity. So it kind of happens on the go, basically.
Right.
So for those kids, it really works well because they would love to play a certain sport. You just fine tune it so it involves some math concepts, and you get the kids motivated that way as well.
Yeah, very interesting. Thank you.
I had a question about whether it's hard to find participants and how many you feel you have to have for this study design.
Is it hard for us to find participants?
Yeah,
Just
recruitment and
I mean,
numbers.
yeah, for sure. I was terrified at first, especially
Yeah, me too.
because we worked so hard on streamlining the protocol, and then when it came to recruitment, we're like, oh, we have to find people to be part of it. And no, it's been really easy because we have many clinics and centers affiliated with the Faculty of Ed. So the Mary J. Wright Center, which is with the Marymount Family Support and Crisis Center, and so they have an ADHD group, like a class that runs. So we recruit through there for our special pops, and then the Child and Youth Development Clinic, which also assesses kids with ADHD, many of them. So we've been doing fine with that, and we only need about 20 kids with ADHD, and then 20 age-matched, typically developing controls, which we are just going to recruit from the community. So advertising through, the London Museum, at different sports camps, because they're going to be summertime soon. So yeah, we're okay so far, but I was definitely worried. There was many moments of panic where I wasn't sure. But we're also, our reimbursement, like they're being paid a decent amount of money to participate. So I think that helps a lot for these families. So that's definitely incentive too for them to participate. So I think that with that combination of things, access to resources and financial reimbursement, it's been okay. Do you have issues with that? Or?
No, it's just participation is getting harder and harder to come by in research these days in education settings. So,
yeah.
But right now you're not in schools. So
right.
Like trying to do research in a board, there's a whole other ethical hurdle to get through now.
Yeah, it's interesting because I was, we were told September, October-ish by, members of different school boards, that it's not an ideal time within London to even do classroom-based research, because something like principals are covering upwards of 9-10 classes because of teacher shortage. So yeah, luckily this research right now is lab-based, but in the next year or two it's going to move into classrooms, and so we'll see how that goes. But yeah.
One thing you might consider once you've got some baseline effects is in branching out into working with teachers.
Mm-hmm.
Like the example I gave, like perhaps that teacher might be interested in what effects her intervention is having. How might your technology help answer her question? I sense, as a teacher and a researcher, that and knowing some of the policy context in Ontario, that there'll be more interest in co-researching them. Especially when you think about long-term sustainability. How do we motivate people to continue on with something? Well, they need to invest into it in some way.
Interesting. Yeah, that's a great point.
Motivations and questions. Yeah.
Yeah, no, that's great. Definitely something to think about. So that was it, and then my thank you slide of all the people, groups, resources, friends and family who put up with me. So yeah, I know that you guys have been asking questions throughout, but are there any remaining ones?
Yeah, I have one more question regarding, are you interested in exercising while doing a certain task? I've seen this somewhere.
Yeah.
It was for ADHD students specifically. They had some kinds of bikes beneath their desks.
Yep.
And they were doing some kind of
yeah, that's like
not
so.
biking, this bicycling activity while they are performing some cognitive tasks.
Yeah, so there's a
problems.
relatively new area of research called what is it called? Not sedentary. Anyways, I can't remember the exact line of research, like the name of it, but it's looking at sort of, oh yes, it's seat-based physical activity, so sitting in a desk with just desk bike pedals underneath your desk, whether, that would also be, you're not getting up and you're not doing something that's instructor-led, but you're still engaging in some physical activity. So I actually, in my request for purchasing the FNIRS equipment, I also asked for 30 bike pedals to be able to bring those into a classroom, and just, I forget which one of you mentioned it, but just having access to some form of physical activity outlet for kids that, need to just get rid of some excess energy, which is normal. I think we forget that kids are supposed to be running around and, getting out their energy. That's a normal part of development. It's actually healthy. I think it's viewed as, dysfunctional just because of the current cultural context in which you sit in class for so long. But yeah, so that's a line of research that I'm hoping to, given that those resources are afforded to me, to look into, because there is some research that shows even just sitting on things like stability balls as your seat while you're working forces you to engage your core, so it's sort of an active seated position, and that actually is beneficial for your ability to stay on task longer. So it's not even necessarily physical activity in the traditional sense that we think of it. So yeah, there's a lot of really interesting things that I think are going to be coming out of that too. Oh, it's called dynamic seating. That is the term. I knew it would come back. Anything else?
Well, take a moment and thank Barbara for her great talk today. Thank everybody for coming today. It's great, and so we've got another talk coming up on guest speaker on Friday morning, and that's it kind of for the time being, but keep your eyes on the events calendar and post things as they come, and we'll see everybody back for the 2019-2020 Faculty Summer Series in September.
Awesome. Thank you. Oh, did it work? Okay. Oh.